Okay, the COMSOL class. The homework is to make a cantilever like this, like length 1000 something, height something, and width something. So first we need to make the 3D. No, he asked us to first create the 2D plot, then we'll make the 3D. For 2D, you click 2D and then click yes, and then structural mechanics, solid mechanics, right button, add select. After some time it will come under selected physics, and then next. And then normally the most commonly we use stationary and time dependent. Right now we have to use stationary, and then click finish. The first thing we need to do is change the length to micrometer, and then add material, right button, open material browser, then MEMS, semiconductors, silicon, right button, add material to model. Then go to geometry, right button, rectangle. Inside the solid mechanics, you have to provide the thickness. In this case, the thickness is around 20 micrometer. So 20 e raised to minus 6. 20 e raised to minus 6 meter. And okay, now the rectangle, click rectangle, then that you have to choose the dimension of the rectangle. In my case, the width, the height is around 100, and width is around 1050. After choosing that, you can generate the plot. This will be the plot, and then we are making a cantilever, so we have to fix one side. So we have to right click on the solid mechanics, and then select fixed constraint, and then select this side for fixing. Just left click first time, then right click the mouse button, so it turns blue. Then we have to again go to solid mechanics, click right button, then add boundary load. Boundary load, we are giving it on the rightmost corner. So first left click and then right click, and then choose the load type to total force. In this case, we are applying the load from top, from here, so it's on the y-axis, so you have to give it in the y-axis. 10 e raised to minus 3 Newton. It's okay. 10 e raised to minus 3 Newton. Then you have to go to study, right button, and then compute. So we got the deformation. Right now it's in the positive x direction. If you want to change the direction of the force, again go to boundary load and give the force value as negative. And again study, compute. So in the stress, in the results, you can go to stress, surface, and then deformation. Inside the deformation, it shows the scale factor is actually defaulted to 4. This is not the actual force. This is just a 5 times scaling, just to make us see the difference between the force and not giving the force. Here you can choose between 1, just to see how much scaling one has, and then click on plot button, and it just shows a small deviation. In order to see this deviation bit more, that's why it automatically gives more than one scaling. So this is the 2D representation, and for the 3D representation we have to again open another window. Okay, for doing the 3D plot you have to select 3D, then again structural mechanics, solid mechanics, add selected. Next, then stationary, right button, no, just finish. Length micrometer, then materials, right button, open material browser, MEMS, semiconductors, silicon, right button, add. Then geometry, right button, block. Inside the block you can give the give the definite length, breadth and height. And then build all. So your block is built, and then as before, just go to solid mechanics, right button, fixed constraint, and then you have to choose the plane. Left click and then right click, it has to turn blue, then that plane is fixed. Now for the boundary lower, you rotate the image, then click left click again, then right click, and then again total force. Now right now you have to apply the force in the opposite z direction going down. So in z I'll add the direction minus 10 e raised to minus 3. Okay, then steady compute. It's the same thing will show. The 2D and the 3D should somewhat match, but it depends on the load and the size. You can see the scale factor is only 2. If we give 5, it will almost be the same. 2D and 3D. And you can generate the report by right clicking on the report and brief report, and then select Word document, then write. So everything you did will be compiled into a Word document. It can be easily used anywhere else. Another thing is you can also add, this is the report. Another thing is you can also add parameters in global definitions. You can main parameters are parameter, then functions. You can select a RAM function and variables. Yeah, these three you can add. And for parameters you can add length, width and breadth and stuff like that. Another thing to notice, for